Finally, the last one. Number 8. dx dt. We have addition here, so we're just taking the derivative of each one separately. Derivative of t is just 1, plus derivative of cosine is negative sine, so we have 1 minus sine of t. dy dt, derivative of 2 is 0, plus derivative of sine is cosine. So dy dx, dy dt, which is cosine of t, all over dx dt, 1 minus sine of t. So this one can't simplify like we did in number 7. We're going to have to go ahead and use the quotient rule again. So the second derivative with respect to x, so that means when we're taking the derivative of t, we have to multiply by dt dx. Derivative of cosine, negative sine of t, times dt dx, times our denominator, minus numerator, cosine of t, times the derivative of the denominator, so derivative of 1 is 0, derivative of negative sine is negative cosine, and we have to multiply by dt dx. So we have negative cosine of t times negative cosine of t dt dx. Sorry, that's a little smushed. All over the denominator squared. So we can go ahead and simplify the top a little bit. We get negative sine of t dt dx plus sine squared of t times dt dx. Multiply these, we get plus cosine squared of dt dx. And that's all over 1 minus sine of t squared. Alright, so at this point, no combining of like terms yet, so we can go ahead and get rid of these dt dx's by multiplying top and bottom by dx dt. That's going to get rid of all of our dt dx's on the top. So we have negative sine of t plus sine squared plus cosine squared all over 1 minus sine squared times dx dt, which is 1 minus sine. So remember, that's just going to give us 1 minus sine cubed. There is one more thing that we can simplify here. Actually, a couple things, but one to start with. What's sine squared plus cosine squared? That would be 1. So we end up with 1 for all of this. So 1 minus sine of t all over 1 minus sine of t cubed. So we can do a little bit more simplifying here. We have basically, it's like 1 minus sine of t to the first over 1 minus sine of t cubed. So we end up with 1 over 1 minus sine of t squared for our second derivative.